Hey everyone, have you ever, just stopped and looked at a slice of bread and wondered, how does this happen? It seems so simple, right? Well, today we're gonna peek behind the curtain. We're diving into the secret chemistry that turns a few basic ingredients into, well, something pretty amazing. I mean, just look at that. That perfect golden crust. You can almost hear the crunch. And you just know the inside is gonna be soft and fluffy. It's comfort food at its absolute best. But here's the thing, this isn't magic. It's not an accident. It's a full-on symphony of chemical reactions, all happening in a very specific order.
So yeah, that's the big question, isn't it? How on earth do you get that from just 4 simple things? Flour, water, yeast, and salt. That's what we're here to figure out. Let's get into it.
All right, so here's our game plan. We'll start with the essential ingredients, the cast of characters. Then we'll see how they build the gluten network. After that, we'll talk about yeast, the living engine, and salt, the unsung hero. Then it's into the oven for the grand finale, and we'll finish up with why bread goes stale. Ready? Okay, first things first. Let's meet the main players in this whole operation. It's like a play, and these are our 4 lead actors. So you've got flour, that's your structure, the backbone of the whole thing. Water is the activator, nothing happens until it shows up. Yeast, that's the engine, it's what gives the bread its life and its lift. And then there's salt, think of it as the director, keeping everything in line and on schedule. So the story really kicks off the second flour and water get together. This is where the magic begins, where we build the actual foundation of the bread.
Okay, this is super cool. What you're looking at is what's happening on a microscopic level. Inside flour, you've got these 2 proteins, gliadin and glutenin, and they're all coiled up. But as soon as you add water, bam, they uncoil, they grab onto each other, and they form this amazing, stretchy, elastic web. That's gluten, and that's where dough gets its signature stretch.
And believe me, the amount of water you add is, well, it's everything. It's a real balancing act. If you don't add enough, your dough is going to be dry, stiff, and the bread will be dense. Add too much, and you've got a sticky, gooey mess that's impossible to work with. Getting that hydration just right, that water absorption, is one of the biggest keys to making great bread. All right, now it's time to bring in the muscle, the powerhouse. We're talking about yeast. And you gotta remember, yeast isn't just some powder. It's a living thing, a tiny organism that is literally going to breathe life into our dough. So how does this little engine work? It's actually pretty simple. First, the yeast has these enzymes that act like little scissors, snipping up the starch from the flour into simple sugars, basically glucose. Then, the yeast eats that sugar for energy. And as it eats, it burps. It releases 2 things: ethanol, which gives bread that amazing smell and taste, and carbon dioxide gas. And this is where it all comes together. Remember that stretchy gluten network we built? Well, think of it like millions of tiny little balloons. And as the yeast is producing all that CO2 gas, it's blowing up every single one of those balloons. That is literally what makes dough rise. It's trapped gas, and it's what gives us that light, airy texture we love. Okay, let's talk about the unsung hero of this whole story. Salt. You're probably thinking, yeah, it makes it taste good. And you're right, but oh boy, it does so much more. Salt is a total multitasker. Check this out. Salt has 4 key jobs. 1, it actually strengthens that gluten network, makes it even more elastic. 2, it slows down the yeast. It keeps it from going absolutely crazy and fermenting too fast. 3, yes, of course, flavor and aroma. And 4, by slowing down the yeast, it makes sure there's some sugar left over at the end, which is crucial for getting a nice brown crust in the oven. See? It's totally the director, controlling the pace of everything. And hey, don't just take my word for it. Le Saffre, who are experts in this stuff, put it perfectly. Without salt, bread tastes bland and less aromatic. Basically, bread is not very appetizing and rather lifeless without salt. Couldn't have said it better myself. It's just essential. Okay, everything we've done so far has been leading up to this moment. It's time for the grand finale, the oven. This is where all that chemistry gets locked in and transformed into actual bread. So as soon as that dough hits the heat, a whole bunch of things happen really fast. First, the yeast has a final panic moment. We call it oven spring, where it goes wild and produces a last burst of gas before it dies at around 46 Celsius. Then, as it gets hotter, the starch is set, locking in the structure. And finally, once you get above 140 degrees, you get the Maillard reaction. That's the magical browning process that gives the crust its color and so much of its flavor. Let's zoom in on that middle step for a second, because it is so important. Starch gelatinization. That's a fancy way of saying the starch granules suck up all the available water, swell up like crazy, and basically set like concrete. This is what turns a wet dough into a solid loaf. If this didn't happen, your bread would just collapse into a puddle as soon as you took it out of the oven.
So the bread is baked, it's beautiful, but the story isn't quite over. There's one last chapter, a kind of sad but fascinating one, staling. Why does that perfect fresh loaf always go hard?
Now, most people think staling is just the bread drying out, but that's not the whole story. The real culprit is something called starch retrogradation. Basically, after baking, all those starch molecules are relaxed and soft. But over time, they start to tense up again, rearranging themselves back into a more rigid, crystalline structure. That change in structure is what makes the bread firm and brittle. But here's the good news. You can use science to fight back. And here's the biggest tip. You ready? Do not put your bread in the fridge. That recrystallizing process happens fastest at cold temperatures. So the fridge is literally the worst place for it. Keep it at room temp. Also, things like baking it a little lower and slower can help. And of course, the ultimate trick, just toast it. That blast of heat temporarily breaks up those crystals and makes the bread soft again. Science to the rescue.
So after all that, what do you think? Is baking a timeless art? Or is it just a beautiful chemical experiment you can do in your kitchen? I kind of think the real answer, the magic of it all, is that it's a little bit of both. Something to think about next time you make a sandwich, right?